Hello, my name is Henrique Rocha, and this is my project on climate and weather. This focuses on solar exposure against temperature across 6 towns that I'll get into real shortly. So, this report here talks about statistical analysis findings of whether or not the question can be answered about the project that displays data about 6 different towns, 3 coastal, Warrnambool, Torquay, and Lakes Entrance. And in contrast, 3 inland towns, which are Ararat, Castlemaine, and Wangaratta. And the question is there more soil exposure on a monthly average in inland towns than coastal towns, resulting in a higher monthly average temperature? Well, in order to answer that question, the following data in the next page was acquired to create a bivariate and univariate pattern analysis over the last 5 years, from 2017 till last year, which is 2021, all thanks to the Australian Government of Meteorology, which have provided all the data values. And the aim, that you'd like to call it, or the reason behind this project, is to aim and see if it is true that the further away a town is from the sea, the higher monthly average max temperature the town is going to have due to more solar exposure. So the analysis and findings. So here below are 2 tables of data values. These values represent the monthly average solar exposure throughout the 12 months over the last 5 years, so January to December 2017 to 2021. The blue table represents one of the coastal towns, which is Warrnambool in this case, and the data values are the monthly averages of solar exposure. And same one here, but this time in orange, which are one of the inland towns, which is Ararat. And same here, but this time monthly average high temperatures for both towns. And it's just 2 towns, but out of 6, here are other 4 examples: so monthly high average temperature and the monthly average solar exposure: Torquay, Lakes Entrance, Castlemaine, and Wangaratta. Another calculation that was done to confirm that inland towns on average have higher max temperatures was creating scatter plots to determine linearity and how much percent of the high average temperatures are associated with monthly average solar exposure. So based on scatter plots between Warrnambool and Ararat over the last 5 years, I have 2 scatter plots. So the blue is Warrnambool of 2017, comparing the 2 variables, and same here with the brown one, which is Ararat in 2017 as well. And as you can see, the R squared and R values are higher in Ararat, and Ararat being an inland town, than Warrnambool, which is a coastal town. And because of that, it's more consistent with the 2 variables. Unlike coastal towns like Warrnambool might have an unknown variable, a third variable, which you could call it is the sea, maybe the ocean, which affects the 2 variables and therefore causing more chance of rainfall and obviously colder winds because of the nearby sea. And the same thing done with the 4 other towns as well. On average, all inland towns do have a higher variance than coastal towns. And to do that, I'll show calculations. So with the R squared values, which talks about coefficient determination, so it talks about a variable and its variation of a variable, which can be explained by a variation of another variable. So for Warrnambool, I added all the R squared values. So from 2017 here to 2021, I added it all up, divided it by 5 because of the 5 years from 2017 to 2021. I got a result. Then you multiply it by 100, convert it to a percentage, and I got around 64.6%. And concluded, I said approximately 64.6% of the variation of monthly average temperatures can be explained by variation in monthly averages of solar exposure. And if you look into Ararat, it has a significantly higher percentage of 80.25. So it can be said that on a monthly average, inland towns like Ararat can get more solar exposure and therefore have a higher max temperature than, let's say, towns like Warrnambool, which are right along the coast near the sea, which have colder temperatures and do not have as much solar exposure. 5 number summaries. So here is a box. So the orange box here represents Wangaratta from 2017, and the blue one is Lakes Entrance from 2017 as well. And as you can see, it's got the minimum value, the Q1, which lies between the highest value within the first quarter of values and the lowest of second quarter of values, the median, which is the middle value, Q3, which is pretty much the opposite of Q1, and your maximum. And then you got your mean values as well, your averages, which still they all lie higher than Lakes Entrance, which you can say that on average inland towns do experience more solar exposure and have higher monthly average temperatures. And here's a little box of explaining the 5 number summaries here as well. Another interesting thing that was picked from the following box plots here, which contain all the numbers from the 5 number summaries throughout the 5 years. So this one here is Warrnambool, and the other one here is Wangaratta. And here is the trend here. So with the data spread from 2017, it is rather really spread out, whereas 2021 is mostly compressed. So in other words, the IQR, which is Q3 minus Q1, gets lower and lower as the years come by if you ignore the whiskers at both ends. And then conclusion, was this analysis a success? With all the findings that have been mentioned before, it is safe to say that inland towns do have more solar exposure on a monthly average and therefore have a higher monthly average temperature, unlike coastal towns, due to a third variable, most likely being close to the ocean. And reasons being is that there was a strong correlation between the variables on inland towns compared to coastal towns, and again, that third variable having the effect to weaken the correlation of coastal towns in the end.